Hello, my dear students. This is Mrs. Shaymah Gharib and today's lesson about data handling. In this video, we are going to talk about different types of data, such as categorical data, discrete data, and continuous data. Let's revise some rules before we watch any video. First, we have to sit in a quiet place. You should have your pen and a piece of paper to take notes and to solve questions. You should pause the video after each question, then you try to answer on your own. Then you play the video to check your answer and to understand the question in case you get a wrong answer. Are you ready? Let's start. Let's start by categorical data. Categorical data describes a way of sorting and presenting the information in a report. Numbers are collected in groups or categories. It takes on names or labels, such as this example here. Can you see the data here are names of fruits? And the data here in this pie chart are types of cars. It also has a finite number of categories. It might not have a logical order. What does this mean? Look at the order of the fruits in this example. Does the order matter here? If I changed the places of the fruits, would this affect the data? No, at all. If I started by the oranges, or I started by the banana, or I can put the apple at the end of the graph, so the order of the data will not affect anything in the graph. Okay? Examples for categorical data. We can find categorical data in graphs that talk about skills or food or home, hobbies, preferences, etc. Now we are going to talk about discrete and continuous data. They are two different types of information. We'll start with the discrete data. The type of information is numeric variables that have a countable number of values. What the meaning of a countable number? A whole number. For example, look at this graph here. The data here is number of cars sold. So I have 1 car, 2 cars, 3 cars, 4 cars. Can I say 1.5 cars? No, I cannot say 1.5 or 1.1 or 2.3. So the discrete data, the type of information, should be a countable number. It's often referred to as categorical data, such as this example. It uses names and labels. Okay. It might not have a logical order, so the order doesn't matter, such as this example here, the bar chart here. Let's see some examples, such as the number of students in a class. It should be a whole number. The shoe size, look at the shoe size. Let's stop here and think. We have a whole number of shoes and we have also numbers in between. For example, if I have a shoes size 9 and I have a shoes size 10, I also have 9.5, but I don't have 9.1, 9.3, 9.4, and so on. So the shoe sizes are discrete data. The number of siblings and these types of information or this type of data, the discrete data, can be graphically displayed using the bar chart or the dot plot or the waffle diagram or the pie charts. So all these graphs can be used to display the discrete data graphically. Is this clear? Continuous data. Now we are going to talk about the continuous data. Let's see. The type of information here is numeric variables, such as the discrete data. But what is the difference? That it have infinite number of values between any two values. What does this mean? Look at this example. This one, it shows us discrete data example, as we said before, for the number of cars sold. That I cannot have a decimal number of cars. What about the second one? It shows the number of pounds of grapes sold. So it shows the mass of grapes sold. So I can say 1 kilogram or 1 pound, 2 pounds, 3 pounds, 4 pounds. I can also say, or I can find the mass of 1.5 pounds or 1.5 kilogram or 1.25 kilograms or pounds, which is 1.25 kilograms or pounds. Okay, so this is the difference between continuous data and discrete data. So in the continuous data, remember, I can use many decimal numbers between the whole numbers. Some continuous data will change over time, such as the weight of a baby or the mass of a baby in its first year. So I can watch or record the mass of the baby every month. So it will change. I will find that the mass changes over time. Or also I can measure the temperature in a room throughout the day. So I will find that the temperature could change throughout the day. Examples for continuous data: the height, the weight, the mass, the length, and the volume. So it's all about measurements, as you can see. We can display the continuous data graphically using the frequency diagram or line graph or scatter graph. It's really important to know the types of graphs for each type of data. Now let's have some questions. For each of the following, state if the data would be discrete or continuous. The number of people in a room, the mass of a book, as the number of pages in a book, the length of a line, and so on. Let's start by the first example. The number of people in a room. So could it be a decimal number of people? No, which means it is discrete data. The mass of a book. Could it be a different decimal numbers? Yes, it could be a different. I have a variety of different decimal numbers that could be possible for the mass of a book, which means it's a continuous data. The number of pages in a book. Can I have a book with a decimal number of pages? Can I say this book has 234.1 pages? No, which means this type of information is discrete data. The length of a line, yes, continuous, because I can say the line is 3.1 centimeter, 3.9 meter, okay? The time taken to complete a puzzle is continuous. The size of a shoe, we said before, do you remember the example of the shoe? It is discrete data. The number of glasses in a dishwasher, it's discrete data. The volume of water in a bottle is continuous data because it represents volume. The number of songs in an album, what do you think? It's discrete. The weight of an apple or the mass of an apple is continuous. The number of people at a football match, of course, it is discrete data. So now do you know the difference between discrete and continuous data? Let's see one more question. Choose the graph or chart that would be best to represent data for each of these investigations. Let's see the first one. You want to show the favorite subjects in your class. So, which graph would you choose here? So, is it bar chart or line graph or frequency diagram? First, I have to ask myself, what type of data is it? Is it continuous or discrete data? What do you think? Of course, it is discrete data. So I will choose which chart, the bar chart. In the second example, you want to show the temperature changes outside your house during a day. So first question, what type of data is this? Is it discrete data or continuous data? Of course, it is continuous data as it is changes over time throughout a day. So which graph would be best to represent this data? Line graph would be best for describing continuous data. This is the end of our lesson today. Thank you for watching and see you soon.